In this video, I want to talk about graphing a parabola of the form y equals ax² plus bx plus c with integer coefficients. So, for example, we want to graph this parabola, f of x equals 3x² minus 12x plus 13. Now, it's hard to graph a parabola like this because it's not in the format that we know how to graph it. It's better if we can have it in the form y equals a times x minus h squared plus k, and then we know that h comma k is the vertex, right? So let's go ahead and try to put this equation into this form. So f of x is the same as y, so I'll just write y equals, and now in order to get it in this form, the first thing I'm going to do is I'm going to pull out a common factor out of here. So 3 is my common factor, and then it's x squared minus 4x. And then I'm going to leave some space because what I want to do here to get it in this form is I want to complete the square. So then I'm going to leave my plus 13 on the outside. Okay, so this is the goal. So in order to get this into this format, I need to complete the square. So when I complete the square, what I do is I try to figure out what number can I add to this, and then I'm going to have to subtract it out here so that I don't want to, undo anything I'm not going to undo. But what number can I add here so that this can be x, in this case, minus something squared, right? So the question is, what is this number? So if it's x squared minus 4x, then this needs to be minus 2, right? And if this is minus 2, then this number here needs to be plus 4. So x squared minus 4x plus 4 factors into x minus 2, the whole thing squared. That's called completing the square. But when we add 4 here, we're multiplying by 3, so it's actually 12. So we've just added 12 to this equation, so we also need to subtract 12 from it. So we cannot forget that we have to, if we're going to just add something to an equation, we have to subtract it back out somewhere else so that we're not just messing up our equation. Okay, so then the 13 minus the 12 is just plus 1. And this is times 3, and this is what y equals. And this is the format that's actually going to help us graph it. So, in order to figure out that vertex, we have to first put it in this form. But I actually want to show you how to think about it in a different way so that we can also do it another way. But first, let's go ahead and recognize what our vertex is. So the vertex is h comma k, which is 2, 1. Okay. So let's figure out, though, from here, if we could figure out an easier way to find the vertex without having to complete the square. Because completing the square sometimes is easy, but sometimes it can be pretty hard. So if we didn't want to complete the square, let's think about how we got to this number. So this number was, so we started with b, right? It comes from b, and it is this number divided by this number, right? Because we factored out the 12, and that was how we got 4. So we had, this is b, and we had b divided by this number, because we factored that out. So b divided by a, so the vertex, and I'm just going to call it the x vertex because this is just the x coordinate of the vertex, is b divided by a. And then we actually divided to get from the 4, or from this 4 to get to the 2, we divided by 2, right? Because this middle term is the outer plus the inner, so it's 2 times whatever this number is. So this number right here is 2 times this number. So this number divided by 2 is the x-coordinate of the vertex. So it's b divided by 2a. And so this number, the 2, comes from b, which is this part of the vertex, divided by this number, which we factored out. Factoring out is another way of dividing. And then we divided it by 2 to get here. So the x-coordinate of the vertex is always b over 2a. And then, so it's a little bit easier to use b over 2a to find the x-coordinate of the vertex than to complete the square in some cases. So if you don't like completing the square, you can remember that the x-coordinate of the vertex is b over 2a. Now, and it's actually negative b over 2a. Sorry about that. Because remember that it's x minus h. So to get to the minus h was b over 2a, but to get to the to get to the actual vertex, we have to do the opposite. So it's negative b over 2a. And that's how this got us to b over 2a is the minus 2, and then the vertex is just the 2. So it's negative b over 2a. Now there's another way that you might recognize b over 2a, or negative b over 2a, and that's from the quadratic formula. So the quadratic formula has x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you might recognize the b over 2a is this part of the quadratic formula, and that should make sense because the vertex of a parabola, think about a parabola, and say that these are the two x-intercepts, the vertex is right in between them. So the vertex is the negative b over 2a, and then this one is the plus the square root of b squared minus 4ac, and this one is the minus the square root of b squared minus 4ac. The other way that you can think about it is if this part is 0, it just has one root and it just touches down, and that's the vertex. So there's a number of ways of thinking about why the b over 2a makes sense, but in any case, the x-coordinate of the vertex is always negative b over 2a, and I'm going to rewrite that a little bit neater. Okay, so in this case, we found the vertex, and it's 2, 1. So once we graph the vertex 2, 1, we know that this is an up-opening parabola because 3 is positive. But then to figure out a couple of other points on our parabola, we can just make a chart. So if we just make a chart, the thing that we need to remember is that we want to put in x values that are close to the vertex, right? Because otherwise they'll just be like points way off of our graph. So in order to get helpful points, we want to graph points that are close to our vertex. So let's do 0 and 1. We already know 2. And 3 and 4. So 0, 1, 2, 3, and 4. We already know 2 is 2, 1. So if we put in 0, we get 3 times 0, 12 times 0, plus 13. So that's just 13. 1 is 3 times 1, minus 12 times 1, plus 13. Seems like it's going to be 4. And then, now it should be symmetric, right? So, parabolas are the same on both sides of the vertex, so it should be symmetric. Let's just check and make sure. So 3 times 3 squared is 27 minus 36 plus 13. 27 minus 36 plus 13. So this is going to be negative 9, and then this will be plus 13, should be 4. And then 4, so that is symmetric, right? It should be symmetric around the vertex. So we shouldn't really need to figure out what this is, but we'll go ahead and do it just to check. So our last one, 4. So 4 squared is 16. 16 times 3 is 48. Minus 48 plus 13 is just 13. Okay, very good. So those 13s aren't really going to be on our graph, but we can pretend. So here's 1, and here's 1, and those 13s are going to be, somewhere up here. But we'll just keep our graph a little bit smaller than that. And that is how we would graph a parabola of the form y equals ax squared plus bx plus c that has integer coefficients. So remember that the vertex is at h comma k if you complete the square and turn it into an equation like this. But the other option is that you can use the x coordinate of the vertex is equal to negative b over 2a, and you can use that as a starting point instead of doing the work of completing the square.